This is Chapter 12, Section 3, and it's covering acid precipitation. The objectives today are to explain the causes of acid precipitation, to explain how acid precipitation affects plants, soils, and aquatic ecosystems, to describe 3 ways that acid precipitation affects humans, and to describe ways that countries are working together to solve the problem of acid precipitation. So what causes acid precipitation? First, you need to define the word, and acid precipitation is referring to rain, and it's rain or really any other form of water like sleet or snow that contains a high amount of concentration of acid. And what's causing this high concentration of acid is from the pollution of the atmosphere that we've talked about. The different pollutants that are going into the air that are increasing the acidity of them. Those pollutants are primarily sulfuric acid and nitric acid, but you also have carbon dioxide, CO2, that's also going to contribute to acid precipitation. And these are all released primarily from burning of fossil fuels. So when fossil fuels are burned, they release what are known as oxides of sulfur and nitrogen. So these oxides primarily look like sulfur dioxide and nitrogen dioxide. And as I said, you also have carbon dioxide that plays a role in forming acid precipitation, but nitrogen dioxide and sulfur dioxide are going to dissolve better in water, and so they're going to be ones that contribute much more to the acid precipitation than carbon dioxide, although carbon dioxide certainly plays a role in it, especially because we release a lot of carbon dioxide into the atmosphere. So anyways, these gases are going to combine with atmospheric gases and with water to form sulfuric acid, nitric acid, and then carbonic acid is what's coming from carbon dioxide. And what causes acid precipitation is, as I mentioned, the burning of fossil fuels. And so whenever this acidic rainwater or snow or whatever flows over and through the ground, it's going to get into your lakes, your rivers, and your streams. And as we mentioned when we talked about aquatic ecosystems, and just any ecosystem, the animals and plants that are in those ecosystems are designed and have adapted themselves to survive in a certain environment, and part of that environment is being able to live with a certain what's called pH. And so if things get too acidic, that's going to affect their ability to survive and reproduce and continue to live. So what pH is? pH is a way that we measure how acidic or basic, the opposite of acidity, something is. Alkalinity and basicity, those are synonyms. They both go together. So a pH scale goes from 1 to 14, where 1 is more acidic, 14 is more basic or less acidic. And each time you go a whole number, so as you go from 1 to 2 to 3 and so on, you're actually increasing not by 1 but by 10. So this is times 10 times 10. So a 3 on the pH scale is actually 10 times 10 is 100. A 3 is actually 100 times more acidic than a 1. Pure water is going to have a pH of 7, which is right in the middle of the pH scale. And then normal precipitation is usually about 5.6, and that's because we have those the carbon dioxide, all the sulfur dioxide, nitrogen dioxide, all those different oxides that are going to contribute to lowering the pH. So if you're at 7, you're considered neutral. If you're lower than 7, you're acidic, and if you're greater than 7, you're basic. And this is something of a visual showing you the scale. So again, 7 is pure water, and then you get more acidic, less acidic. So just to kind of give you an idea of everyday items and where they fall on the pH scale, so the most acidic stuff is going to be something like lemon juice. and then the most basic is going to be something like ammonia. Human saliva is right around 7, and then as we mentioned, normal rain is going to be slightly acidic. And then if it's extreme acid rain, you're actually right around 3.5 to 4. When you drink a carbonated soda, you're a little above 3, and your detergents are going to be more basic. So kind of the formal, I guess, cutoff for what is acid precipitation, what it's not, is typically going to be right at 5. If you're below 5, that's when you kind of start saying that's acid precipitation. If you're above 5, then it's just kind of normal rain, for the most part. And the pH of precipitation is going to vary depending on where you're at. So if you're in the eastern U.S. and Canada, you're going to be between 4.2 and 4.8, where Lake Erie and Lake Ontario are going to be the most acidic places. But maybe some rural area in Montana where you don't have a whole lot of cars driving around or industry adding all those oxides into the atmosphere, the pH of the rain might be more like 5.5 or 5.6 or maybe even like 6. So it just depends on where you're at in the world is going to determine the pH of the rain. So why do we care about acid precipitation? Like, what does it do? And specifically, how acid precipitation is going to harm the environment is it's going to cause a drop in the pH of the soil and water, which is kind of obvious because the rain is itself acidic. And anytime just some terminology, anytime you increase the concentration of an acid, that's going to be called acidification. And so when the acidity of soil increases, some of those nutrients that are kind of inside your soil and attaching themselves to the little grains of the soil, whenever the acidity of the water going through that soil increases, those nutrients are going to dissolve into that water and they can get washed away with that rainwater. Meaning that you're going to have fewer soils, you're going to have fewer nutrients left in your soil for your plants to utilize. And in addition, you're also going to cause some toxic metals like aluminum that normally will stay kind of attached to the particles of soil and not affect the plants. They won't get absorbed into the plants. Those will get released into the water, and those can start to be absorbed by the roots of the plant, causing root damage. And if you damage the roots of the plant, you're ultimately going to be damaging the plant as a whole because you're damaging the supply line. And in addition to that, sulfur dioxide, while also making rain more acidic, it also when it's in the water vapor, it literally will clog the openings on the leaves of plants, reducing their ability to bring in that carbon dioxide and release their oxygen. As we've kind of already mentioned, acid precipitation is going to drop the pH of water, which isn't good for the plants and animals. And the same thing that happens on land is going to apply also to the soil and aquatic ecosystems, where if the water is more acidic, that's going to cause those toxic metals to get released, and those toxic metals can harm the plants, and they also can be floating around in the water. And when the fish are swimming in there and they're filtering that water through their gills, that aluminum is going to start to build up in the gills of the fish. And that aluminum will, think of like a little drain that, maybe starts filling up with hair or something. It's, aluminum just kind of acts like that hair that slowly starts to block the exchange of oxygen and salt that's normally going on in the gills of fish. And so the fish literally start to slowly but surely suffocate, kind of like a drain will slowly start to kind of back up. Acid shock is going to happen whenever you have some sort of sudden input of really acidic water. And this is primarily going to happen whenever you have snow that starts to melt in the spring, where, all that water is still, just because, water freezes or becomes snow doesn't mean it's no longer acidic. It's just water that's in a different physical form. So whenever that snow melts, all that water is going to rush into the aquatic ecosystems. It can start to really dissolve down into the soil, or you can get a heavy rain that can follow certain droughts. And anytime any of that's happening, we just call it acid shock. And so that drastic drop over a short period of time is going to cause a large number of fish to die, and plants, just because they have no time to adapt to it or maybe to change areas. An example would be with fish and amphibians. You're going to get fewer eggs, and then the eggs that do survive aren't going to be able to hatch as often, meaning that you're not going to have fewer offspring that survive and reproduce, and the offspring that even do survive are going to have an increased risk for birth defects. Another thing to think about is, we eat these fish. So if you have a fish that's getting more of these toxic metals that build up in its gills, and then you as a fisherman or you as a consumer, you catch and you eat that fish, you're being exposed to those toxic metals. And just like those toxic metals are bad for the plants and animals, they're also bad for you because you are an animal. And so, this that's really, maybe as humans, maybe like the ultimate reason why we do care, other than just, save the animals, is that this ultimately comes back to haunt us. And there's also research that will indicate that certain respiratory problems can begin to increase in communities that are going to have more acid rain. And beyond just wanting to have clean fish to eat, a lot of people depending on fishing and depend on forestry for their livelihoods. And so a commercial fisherman or a forester will have fewer trees they chop down or fewer fish to catch if you have acid rain killing off the fish or damaging trees. And then a lot of concrete, and the marble historical monuments we have, all of those are at risk from acid precipitation, because slowly but surely that acid can start to dissolve that calcium carbonate that's in those building materials. And so it has consequences on these structures that we build. And so the point here is that there's actual economic consequences that occur with acid precipitation, that's in addition to save the plants and save the animals. One thing that that makes things difficult with trying to control acid precipitation is that it's a very, we have our countries and our land that we divide up and say this is one country and that's another country, but nature doesn't really follow those rules so much, where acid precipitation that's falling in Canada will oftentimes be produced in the northeastern United States. And so it becomes who's responsible for that, and it gets into this tricky thing where, because you're not, it's kind of out of sight, out of mind, because the ones who are producing the pollution aren't the ones who are feeling the bulk of the side effects. They don't really have as much of a motivation to be fixing that issue. As opposed to if they're the one, if it's something like smog, where you're the ones producing the smog, it's directly affecting you. But if it's the acid rains going somewhere else, and it's kind of, you don't really worry about it as much. And this is a map showing in green the areas that are primarily producing the pollutants that are leading to the acid rain, and then in blue are the areas that are the ones that are mostly feeling the consequences of it. And then purple is going to be those areas of the world that are at a significant risk for acid precipitation. Final slide. So, despite all of this, there has been, some sort of international cooperation that's been going on. One example is the Canada-U.S. Air Quality Agreement of 1991, where both countries agreed to reduce their acidic emissions that are flowing across that Canada-U.S. boundary. And then you have similar agreements in Europe. And while these aren't the end-all be-all, they have made some sort of progress to reducing the amount of sulfur dioxide and other oxide type emissions that are contributing to the acid rain. All right, that's going to do it for this lecture.